Welcome back, everybody, to Geometry with Coach Foss. Today, area of sectors and arc lengths. I know we already got through our unit with circles. This is a little bit more talk about circles. So let's take a look at a circle. So simple ideas. First, we remember that every circle has a center. Well, we want to try and understand some basic concepts. If I wanted to find the area of this circle, that's something you learned in middle school. If you wanted area, that would be pi times the radius squared. All right, so if we're talking about area of, but this doesn't say the word circle. What a sector is by definition, it's a portion of a circle. All right. Think of it as a piece of pie. So a sector, all right, if we wanted the entire circle, we would use this formula. A sector is the idea, and it would totally make sense if I wanted to find the area of this much of the circle. You might realize, well, let's just take the area. And if I wanted the area of just this part, then for this example, we would just want 1/4 of the area of the circle. Okay, which that's just fine. We can do that. Where it gets a little bit more difficult, where we get a little bit more confused, is, well, what if it wasn't something simple? What if I wanted, say, that our central angle was 60 degrees? What if I wanted this much of the circle? Well, I want you to really stay composed. So before, right, this talked about, well, how much of the circle, the amount, all right? And this formula found area, okay? Well, the way we're going to try and discuss the amount of the circles, we want to find out, well, here we wanted 90 degrees out of the 360 degrees. Well, 90 divided by 360 is 1/4 of the circle. So the formula we're going to use to find the area of just this portion of the circle is, we want to know, well, how many degrees out of the 360 are you going to want? We're going to take this times the area of the circle. This is our formula for area of a sector. The two items that we would need to know, radius and how many degrees. So let's see, our radius was 10. We could work through a quick little example of this problem here. And to do this, we would want to know, okay, we want 60 degrees out of 360 times pi times 10 squared. All right, now some of our answers you might be told to leave your answer in terms of pi. Now, pi, Pi, is different than PIE. PIE is what we eat. Pi is that symbol that looks like this. So what that means, if we want to leave our answer in terms of pi, then we would handle all the numeric side of this, and we would leave pi out of it. So, here's my calculator that doesn't work. Here's the one that does work. Live TV here. All right. So just watch how simple I can do this. I'm just going to basically put into the calculator 60 divided by 360 times 10 squared. Now, If I get a decimal like this, if I'm going to leave it in terms of pi, our goal, if we're leaving in terms of pi, is to not round, to have a precise answer. So I don't want to put 16.67 or anything like that. I'm going to use the calculator. I'm going to use the math function. I'm going to hit the math button, and I'm going to bring that value back to a fraction. So my answer would be 50 over 3 pi, because remember, I didn't put pi into the calculator. The other option, maybe I want to round to the tenths. If you see that, round to a certain value, then we want to put everything into the calculator. So you could have done 60 divided by 360 times 10 squared times, and I can put in the calculator's version of pi, which is right here, using that what's called the caret button. Now, if I put everything in there, then I could do this would be an approximate because I'm going to round. If I rounded to the tenths, this would be 52.4. And please remember, if we're working on an area, if this would be meters, then my area is going to be meters squared. Okay, so very important formula. You're certainly going to want to have this written down in your notes. Area of a sector is so many degrees out of 360 times pi r squared. And so if it makes sense for area of a sector, which is a portion of the area of the circle, when we move over to arc length, please understand the difference between arc length and arc measure. Okay, so if we look at a circle, the difference between those two, let's say we're looking at, so from A over here to B, this is an arc. So the arc measure, we're talking about degrees. So maybe this arc measure here is 120 degrees. So many degrees out of the total circle. Arc length would be if you stand at point A and walk around a circle. Now we're talking about a length, a distance, which could be something like, how many feet did you walk? Which is different. So if I'm going to do arc length, try and remember, if I start at point A and I walk all the way around in a circle, that's called circumference. Well, circumference is 2 pi r. So the only thing I need for circumference is a possible radius. Maybe I know the radius here is 8 feet. The entire circumference would be 16 pi feet, because I just got to put 8 in here. 2 times 8 is 16. If I leave my answer in terms of pi, I get 16 pi feet. Now, arc length is, well, what if we don't want the entire circumference? What if I just want from A to B? Well, we're playing the same game, all right? So our formula for arc length would be how many degrees out of 360, this tells me the portion of the circle I want, times the circumference formula. So if I wanted to work through this example, well, I want 120 degrees out of 360. That's the amount of the circle, times 2 times pi times a radius of 8. Again, if I want to do my answer in terms of pi, I'm going to put all the numbers in. 120 divided by 360 times 2 times 8. That's the calculator's doing the heavy lifting. Again, if I have a decimal, if I'm leaving it in terms of pi, I want to go back to the fraction. If If you don't have a calculator, try and understand. You can do all this reducing by yourself. All right, these zeros would cancel. 12 over 36, all right, is actually the same thing as 1 over 3. And if I have 1 times 2, because this is, if I made this into a fraction, put it over 1. On the top of the fraction, I got 1 times 2 times 8, which is 16. And in the bottom, I got 3 times 1, which is 3. And I didn't put pi. And this is how I leave my answer in terms of pi. 16 over 3 pi feet. Again, if I wanted to multiply and put pi in there, then I could come up with an approximate answer. If I round it to the tenths, this would be 16.8 feet. I wouldn't write pi next to it because pi is now inside of that number. Okay, so the two formulas here. Again, you already know circumference. We just only want a certain portion of the circle. All right, circumference is an old formula for us. Area of a circle is an old formula. We just want a portion of the circle. We don't want everything. All right, so good luck, you guys. Work hard, do well. See you in class.